In this chapter, we're going to gain a fundamental understanding of cut and fill volume measurements. We'll also learn how to create a base and compute a volume, and we'll become familiar with base editing techniques and plane adjustments. We'll also learn how to export and import bases for temporal applications. In the previous chapter, we learned how to make linear and area measurements. Those measurements could be calculated in either 2D or 3D. When referring to 3D area, it's important to understand that while the vertices maintain vertical elevations, the measurement does not account for the volume. Now, a Pix4D mapper does contain a tool set designed specifically to measure volumes. The workflow is very simple. The user identifies where they want to measure by digitizing a polygon around the feature of interest. The polygon will act as a base from which Pix4D mapper calculates the material or the data either above or below the plane of the base. The corresponding terms are known as cut and fill respectively. If we look at this next graphic, the bold black line represents the base. In order to know what cut and fill volumes will be, Pix4D mapper needs the DSM to be generated for reference. Now we'll see in the following chapter, or the next chapter, that DSM is a 3D elevation model. Therefore, step 3 must be processed to gain access to volume measurements tools in Pix4D. We will be working with the pre-processed projects as we did in the previous chapters. Now, the project data and the images are located in the L7 _ data zip folder. Now, by either means of your professor will hand it to you, or you can directly download, copy this L7 data zip file to your desktop, and then unzip it. And then once that occurs, take the L7 data file and move it over to your last name Pix4D file. And once this is complete, what you want to do is open up your file, go to the L7 data file that you unzipped. So go over to the O2 project under L7 data, find the Pix4D file. We'll double click on that to bring up Pix4D. And as before, in the previous chapters, if in fact it cannot locate the images, it will tell you just like this one. And what you'll do is go over to your Pix4D file under the data in the projects, and then look for the images. Select that folder. And then what will happen once it processes a little bit, it will bring up a map view. So at this point, I want you to click the volumes, and it will load the densified point cloud. And now, using the tools that you have previously learned, let's zoom in. And what I want you to do is locate, there's a couple of piles, volumes, right about in there. So let's get in there and take a look at that. So there's a couple of gravel piles in this quarry, and we're going to be measuring the volume. Pix4D mapper allows for multiple bases in one map. The technique of establishing a base is very similar to other digitizing techniques in the software. Each individual base must be identified by the user. Since this is a query, there are many cut and fill examples. And for this lab and for this chapter, we will focus on these two sets of stockpiles. So I want you to zoom in as close as you're comfortable with, so we can get a good look at these two stockpiles. Now, under the objects window up here, you'll see a cylinder, and so you want to click on that. Then I want you to go down into left click the vertice and then go on up. Now, and also I don't want you to worry about if it's imprecise or not. What we're doing is going to go up here, ways, and digitize the next one. And when you're done, do a right click and that will finish it up. And notice when you do, all the green polygon that you see around here will serve as our base. And notice volume 1 dialog has now is present underneath your objects. So what we want to do is click compute at this point. And given the software after a few seconds, when finished, the volumes will be displayed. In addition, the volume constrained within the base will turn red. The red volume indicates the location where the volume, either cut and fill, was actually calculated. If the vertices were digitized just beyond the extent of the piles, then the majority of the volume would be a cut, since piles sit on top of or above the base. If we perform this technique over an open pit, the majority of the volume would be, of course, a fill. The total volume is the difference between the cut and the fill volumes. Of course, mistakes may occur when digitizing this base. The result could be an imprecise polygon. Now we'll talk about how to correct these erroneous bases. Being is that there's no undo button in Pix4D Mapper, a technique is to delete a base. And this can be accomplished by clicking the trash button near the top of the volume 1 window, which is right up there. Now, without deleting, to edit without deleting, the technique would be to adjust the position of the base vertices. The default display of vertices is quite small, as you can see. They look like little green nodes down here, and it helps to change the display of these so we can get a better look at them. So what we're going to do is locate the volume settings, and that's this little symbol there, and we'll click on that button. In the volume settings, we'll click on display, and we're going to adjust the vertice radius slider right here all the way over to the right. Okay, and you notice that those nodes have become quite large. Now you can change the colors to whatever you want, so we can change these to maybe even a red, and or bring it back to some kind of a blue, green, or whatever that you'd like to do, that so we can get some contrast going. And so anyway, notice that the vertices now have the properties as set. So we'll say OK there. And we click on one vertice at a time, and it turns, if we click on, say, that like this one, it turns white. This means you're about to move the position of the vertice. Okay, now what we're going to do is we're going to click and hold it, and to move it. So we click and hold, and then we're going to move that vertice just a little bit, or we'll move this one. And again, you have to click it first, so they turn white, and then click and hold to move. Now, this technique takes practice, of course. And what I'd like you to do, you won't maybe get it right the first time, but be patient. But once positioned, the volume measurements disappear, and a new compute button. At this point, you click on the new compute button, and when you do, you'll have new figures. So try this technique over and over a few times and adjust it and maybe change the colors and to get this technique down. Since every vertex is snapped to the DPC, the vertical elevation of vertices create a triangulated surface. This means that unless the DPC is 100% flat, the properties of the base plane will be somewhat not flat. There are several different base planes adjustments available for us. To get to them, we open the volume again, just like I think we have it already displayed up there, and click the settings, and then notice that the tab says base surfaces, not the display, but the tab that says base surfaces. There's a number of settings. The first one is a default, which is a triangulated. This enables the base plane to take the triangulated properties that we previously mentioned. The fit plane will remove the triangulated from the plane. This ensures that the plane is planar but not necessarily flat or level. The next one, align with the average altitude, will determine the average elevation for all vertices of the base. Pix4D Mapper will then adjust all vertices to the later elevation. This ensures that the base plane is both flat and level. The next one, align with the lowest level, will determine the elevation of the lowest vertex. The software then adjusts all the vertices to that later elevation. This ensures that the base plane is both flat and level. The next one, which is align with the highest point, will determine the elevation of the highest vertex. The software will then adjust, of course, all vertices to this later elevation and ensures that the base plane is flat and level. There also is a custom. It's a numerical value that the user can put in here. The software will then adjust all the vertices to this elevation and ensures that the base plane is both flat and level. For this example, let's click Custom Altitude, and then let's put in 530. Okay, and then we'll say OK. And notice that the base is floating above the piles. Then click the compute, let it compute, to recalculate the new volume. There should only be fill volume, and which there is. It's just strictly fill. So if we wanted to fill to this base plane that we put in here, this is the volume that would be necessary. If we tilt this a bit, okay, the red, remember, the red is actually the material. So the practical scenario would be, this is where if it was a pit, this would show you the base material and even tell you the volume that you have to fill. So let's go back into the same area, and instead of 530, let's put in 520. And notice the base is now resting below the piles. So let's click Compute again to recalculate the new volume measurements. Now, there should only be a cut volume. In that case, there is. So it tells you the volume from that base. Now, it is common that the same area needs to be calculated over time as material moves in or moves out of the site. Now, this can be accomplished by saving the initial base and reusing it in future projects. So let's locate the Export Base button underneath the Objects window. And you'll see that by this little Export button right up there in the Objects window. So you click on that. Now, if you've established other multiple bases, you can choose to export them individually or all at once. For this example, we're just going to click Export. And a window, of course, comes up, and there are many different file formats to export a base. From the drop-down window over here, let's choose the shapefile, and we're going to name this thing Volume 1. And we're going to ensure that we're saving it to the O2 project. which is under the L7 data. And we're going to click Save. And it is now saved as a polygon shapefile. To demonstrate the import function, we need to delete the existing volume 1 from our map. So we'll locate our trash bin, which if you put your mouse over it, it appears right there. So let's delete that. And we're going to say, hey, you bet, let's delete it. And if you notice, it's disappeared. Now let's go up and we're going to import, and we'll import the shapefile, which is surfaces. And we'll open that, and lo and behold, it's back in there again. And also remember that it's really important to export bases as shapefiles or SHP files, because Pix4D Mapper can only import the shapefile. The idea behind this is by importing the base. Once you have the base figured out, now it will then be consistent throughout whatever changes you have. So you can do multiple flights, import this base file, and that's your base, so that you can have accurate calculations of volumes that are going out or coming in. Now in this chapter, we've learned how to create, edit, adjust, import, and export volume measurements. And there are numerous base plane property adjustments available. The import and export tool allows repeatable volume over time. So now let's go up to the project tab, click that, save project as, and then let's ensure that we're in the O2 project file, which we are, and then we're going to name this your last name underscore, and we'll say L7, and then we're going to click the Save button. And we'll wait for that to complete. And once it's done, let's close Pix4D Mapper. Okay. And I want you to navigate to the O2 project folder for L7, which we are in. Okay. And then select both your one, and then right click on that one, and then we're going to send to a compressed folder, and that will begin compressing. And then, of course, once it's finished, it may take a little bit of time, but once it's finished, I want you to deliver this particular compressed file to your professor. And that completes this chapter.